Thank you. I would like to call upon Dr. Chirag Ponwala to chair IEEE SPS Gujarat section to share a few words.
Thank you, Sakshi, and good morning, one and all present over here. Good morning to our guest of today, Professor K.V.S. Harisa. So I am taking an honor to share the activities about SPS chapter Gujarat section initially. Uh, so just a minute. Okay, so this is the our executive committee meet for the year 2021, and this time we have all the activity chairs in our committee. So we can see over here that we have membership development chair, technical activity chair, student and YP chair, professional activity chair, BISP chair. We have digital content chair, newsletter editor. So we have each and every committee chair dedicated for each and every task, and we have given almost equal weightage to the women for the particular our executive committee, so that we have almost they have almost equal opportunity for organizing committee. Next one is the DLDIS talk that generally we are organizing in our chapter, and every year we are planning at least 5 to 6 DLDIS talks for our chapter. In this month only, we have two DA talks. One was already done on the 5th of March by Professor Dong Zhu. Second one will be on the 19th of March by Professor Karthikeyan. And another one is on the 27th March. It's a DIS talk that is by, DIS talk was on the 19th March by Professor Karthikeyan, and then that another one is that by Professor Dimitri on the 27th of March. So these are the three talks we have in the month of March. We have our dedicated NetSIP event also in the month of March, that is the new trends in the signal processing. And this time we have the fourth edition of the NetSIP. And it is the flagship event of the SPS chapter Gujarat section that we had started in the year 2015. And we are getting good response for the same. And fortunately, this year also we have received funding from the SPS USA for organizing this event. So thank you, membership board, for providing us the funding for this particular event also. We have some major events that we have started this time onwards. One is the technical talk series. Every month we are planning to have a good technical speaker with us to provide the deep insight on the particular topic on the image processing machine and the deep learning, wireless communication, etc. So that at least the brainstorming sessions will be there with the experts and members of the SPS chapter Gujarat section. Next one is the women in signal processing. So to increase and promote the visibility and recognition of women in signal processing field, each and every month we are also planning to have one dedicated event for women in signal processing this time onwards. Similarly, we are giving equal weightage to our YP members, and that we are dedicatedly planning events for the YP member also. On the 19th of March itself, we have one dedicated panel discussion for YP members, because we are committed to help young YPs to evaluate their career goals, enhance early career skills, and boost professional networks through these activities. And we are giving some offers to our SPS members also. Number one is that we are providing the application grant to SPS members. It can be, it is open for a student as well as professional members both. As we are certified chapter, SPS is giving us the travel grant for attending ICAS and ICF. That is only one student. One student can be able to attend that either of these two conferences, and that is the privilege as a certified chapter. This time onwards, we are planning to start best paper award for journal publication, and that is dedicated for student members. Discount in registration fees we are planning to give during any event supported by chapter. Priority can be given when we have limited seats during some of the prestigious events to the SPS members. We are planning to have PhD forum as well as UG PG dissertation competition this time. We had this event initially in the 2016, and this time also we want to start it again. Hackathon, we have already started this idea, and we have hackathon today as well as tomorrow in the SPS chapter Gujarat section. And SCAD SPS SB is organizing this event during the 13th and 14th of March. So this event we have already started. And our chapter has received 2 times chapter of the year award, and that is what the one of the achievement to SPS chapter Gujarat section. As well as we are certified chapter. We got the certification in 14, as well as we got certification in 2018 also. So this slide I have added today only. We have around 89 members, and when we have started our journey in the January 2021, actually this year, then it was that figure was around 35. So we have good growth due to the good activities and good support from the SPS. And thank you, membership board, and thank you, Hari sir, for giving us the opportunity. And this is the important thing due to which we are getting membership. That Future 50 code is one of the important criteria through which students members are actually interested to become a member. And the $1 membership is also the one of the important thing that was started by membership board last year onwards, and that is one of the important thing through due to which we have good membership growth in chapter. We have dedicated a SPS membership team. We have Professor Manish Khare with us, who is membership development chair, Harshul Yagnik, who is student and YP chair, Ankit, who is secretary, and myself, who is chair, and we are looking after the membership development related things. We are visible on the social media also, on the Facebook, Twitter, on the YouTube. We are all in all the places we are available with the same name, that is IEEE SPSGS. So anyone can follow us on any of the way. And today's lecture also will be available on the YouTube channel of IEEE SPSGS. So this is all from my end. So thank you very much for giving the time for listening the activities to the related to the SPS Gujarat section. Thank you very much. Over to you, Sakshi.
Thank you so much, Chirag sir. We are the information regarding SPS GS was indeed new for us all. Now, without further ado, I would like to call Dr. K.V.S. Hari to inaugurate the student branch chapter SPS, GSET SPS, and SSET SPS.
Sir, you are muted, sir.
Good morning to all of you, and thank you very much for inviting me to inaugurate and deliver a talk. I'm very happy that the Gujarat SPS chapter is very, very active, and I hope that it will continue to grow. And I see it is a well organized and a well structured set of volunteers. So I wish everyone the best. I'm very happy to inaugurate the IEEE Signal Processing Society SCET Student Branch Chapter and the IEEE Signal Processing Society GCET Student Branch Chapter today. Okay, so first, the inauguration of the Signal Processing Society Sarvajanik College of Engineering and Technology Student Branch Chapter. Congratulations to all of you. I'm supposed to do this. Okay. Congratulations.
Yes, sir. These are the team members.
So very happy to note that there are a lot of young and experienced people who are going to take care of this student branch chapter. Please remember that you are the foundation for our SPS society globally, and welcome to join the Global Student Branch Network. Next, I'm very happy to inaugurate the Signal Process Society G.H. Patel College of Engineering Technology. Very good. Very happy to see again a set of energetic and enthusiastic volunteers. And I hope the rest of the team members will be decided soon. And I again invite you to congratulate you by joining the Global Student Branch Network of SPS.
Thank you, sir. Thank you.
Very much.
Congratulations to both the branch chapters and the founding chairperson. Striving for success without hard work is like trying to harvest where you have not planted. Among us today, we have Dr. K.V.S. Hari in the Department of ECE, Indian Institute of Science, Bangalore. He holds a BE degree from Osmania University, Hyderabad, MTech from IIT Delhi, and PhD from UC San Diego, and has been visiting faculty at Stanford University and affiliate professor at KTH Royal Institute of Technology. His research interests are in signal processing with applications to 5G wireless communication, radar systems, autonomous vehicles, neuroscience, and affordable MRI systems. He is a co-author of an IEEE standard on wireless channel models. He was an editor in EURA SIP's Signal Processing and is currently editor-in-chief of Sadhana, the journal of the Indian Academy of Sciences published by Springer. He is a fellow of the Indian National Academy of Engineering and a fellow of IEEE and also on the board of governors IEEE Signal Processing Society as a vice president membership. I would like, yeah, sir, it is a pleasure to have you with us. It will be a great opportunity for us to know more about SPS.
Thank you very much, Sakshi. Thank you very much, Chirag and others who have invited me to share some of my thoughts here. So uh, let me look at the topic which I would like to share with you, sensing and signal processing for autonomous navigation. I'm very happy to be here. And again, congratulations to the Gujarat section SPS chapter for taking an initiative to ensure that all the members are benefited by technical activities and also increasing the number of student branches in your region. So we all are curious to know what is autonomous navigation. We have heard about it. We must have seen some videos, etc. What I would like to share is our experience in trying to build some signal processing systems for autonomous navigation in IASC. So let me, oops, sorry, that was not the idea. So let us start first with what is navigation, then we will understand what is autonomous navigation. So navigation is basically from moving from one location to another location in a chosen environment, right? And how do we do that? As human beings, let us say we create a scene about the environment using multiple sensors. So as human beings, you may look at it, you may hear about what is happening, you sort of identify and classify and locate the objects in a scene based on these multiple sensors. Okay, so you will identify if it is a road, if it is a pole, if it is a pavement, if it is a vehicle, an auto, and so on and so forth. And then you will evolve a navigation algorithm to move without collision in a safe manner, right? So when you see objects in a scene, and you also see that these objects are moving, you sort of create an algorithm. It could be even crossing a road in a traffic and so on. So now, assisted navigation is basically an in-vehicle driver or a pilot, or a remote driver or a pilot. So now, sometimes you may want to be sitting in a vehicle, but it is remotely piloted. That means there is a communication link between your vehicle and there is a driver who is not sitting in the car, but or in the vehicle, but somewhere outside, but through a communication link drives the vehicle. Autonomous navigation does not require human intervention. So basically, we are supposed to build a vehicle in such a way that it will do the scene analysis, it will identify, classify, locate objects, and then evolve a navigation algorithm on its own. So there have been many reports. This is slightly an older report of 2019, where people have looked at how to use artificial intelligence techniques in order to build autonomous systems. And in this report, it has been shown that there are several countries who are testing autonomous vehicles, and there are many cities who are allowing autonomous vehicles to move around along with their regular traffic, okay, in the world. And these numbers are growing day by day. So the question we have to ask now here is, in the context of India and maybe other countries in our neighborhood, can we drive here autonomously, right? I mean, this is what we see as our traffic. And this was a question posed by Wipro to IISc to understand and say, okay, is it possible for us to build something like an autonomous vehicle which can navigate in this tricky situation? The other problem posed for IAC was by Volvo, where they asked, can you drive autonomous vehicle in this mine? This is a coal mine where every day the mine is excavated. There is an explosion every day which happens, and you keep going deeper and deeper into the earth and collect the material, transport it up to a site, and that is then transported to the refinery. Okay, so is it possible for us to look at driving autonomous vehicles? Here it is, you don't have the chaotic Indian traffic, but then you don't have proper roads. These are all muddy roads, and you can see that these are all a different kind of scenario for a vehicle. So, in order to build such a solution for such problems, we started on looking at a project. The first project I will describe is about the Volvo project. Okay, this project was called Envelope: Environment Perception and Vehicle Localization using Peripheral Sensors. And this we had an IAC team, and we also had a Volvo team, and both of us together, we first wanted to build a data collection platform. And the idea of the whole project was Volvo was very clear that they don't want to use expensive sensors. They only want to use webcams. Okay, they just want to use stereo camera based solution, because they said that we would like to see what a simple solution of using simple webcams can do. So the whole task for us was to see whether we can do simultaneous localization and mapping using webcams, and also using the webcams, can we do collision avoidance, but using neural networks. So we all know that collision avoidance can be done using proximity sensors, but they said only image based. Obviously, it will work only during the day, but this was like a pilot project. Okay. So what is it that, how do we go about designing systems in autonomous driving? Is to look at role of embedded systems. So you have to first sense, you have to compute, you communicate, and then you control. So this is typically a framework of an embedded system in various other applications also, but also in autonomous driving. So first you have to sense. That means I need to have a set of sensors like GPS, inertial measurement units, cameras. And then you need to compute, you need to process them. And then, of course, you need to communicate to different parts of the vehicle using communication medium like CAN bus, Ethernet, and maybe wireless. And then you have to control. Suppose you want to apply a brake of a vehicle on seeing an obstacle, then you need to apply, actuate, and control. So the project overview of the project we had was to first start building a data set. So we do data collection, then we do data analysis, then we run some algorithms, build some algorithms to understand this data, and then see how to implement it in the system. So as I said, there are two projects, two tasks which were given to us, whether you can do localization and mapping and to do forward collision. So a typical machine learning or AI based system development includes the following steps. You first create a data platform. You construct with appropriate sensors. So you sort of collect data. So for that, you need to have good quality data, and you need to collect this data for different scenarios. Okay. So the quality of data is very, very important. That also means that the data platform should have very good quality sensors. And after you collect the data for different scenarios, you have to do accurate annotation of collected data. So you need to annotate. Annotation means labeling. So suppose in the data, suppose it is a camera data, in the image, you need to identify where the vehicle is, where there is a tree, where there is a road, where there is another vehicle, and so on and so forth. And then after you do all this labeling, you can then develop various algorithms to carry out, to understand how to carry out different tasks of navigation. Okay. And then once you develop these algorithms in a simulation environment, you have to do extensive testing and verification in both simulations and in the real world. So first you run it on simulators like your desktops or neural machines or GPUs and so on and so forth. And then you have to start testing it out in the field. And only after extensive testing and with safety regulations, you can then deploy the verified system. So this is a typical development pipeline for autonomous navigation, or in fact for any other system development using machine learning and AI based algorithms. So the first task was to look at simultaneous localization and mapping. So obviously we wanted to see what is available in the market, and so we bought a system called Z Stereo. So as you all know, a stereo system can give you depth information. And these were two cameras separated by about 120 mm. And this unit will provide you a a depth information. And using that, you can localize and map. That means if I put this camera on a vehicle and I drive around, it will be in a position to capture the scene and do some mapping. And next time I drive around, it will tell me where I am based on the image it captures using these cameras. So this is the stereo camera. But then the challenge for us was to see whether we can use simple webcams and build our own algorithm. Okay, so you wanted to build our own algorithm like the Z camera by looking at the algorithm development. So if you look at this images, what you can see on the right column, that is the second column of this, you will see that the left and the right camera on the top row is the scene which is seen by these two webcams. And the bottom row tells you the algorithm which was developed in IISc using different computer vision algorithms and finding the depth. This is called a depth map in the lower one. And the right side one is the one which is available commercially, which is the Z SDK. So as you can notice that the implementation, which was built by collecting information from these two Logitech cameras, has reasonably good quality of depth information. So using this, we were in a position to understand how we can build signal processing algorithms on our own. Because when you buy this Z camera, you will only get the output, but you will not know what is happening inside. So the whole idea of doing research is to see how to build our own algorithms, and using that means you need to go to the basics and try to understand what is happening. So this is just to give you an illustration of that we can build our own algorithms by using things which are off the shelf, and a simple two Logitech webcams were used in this. The next task is basically, so maybe I will go. So how do I test whether my system is working or not, right? So Volvo wanted to test this uh, depth camera solution which we have developed, and this is the Google Map image of the Volvo test track in Hoskote near Bangalore. As you can see on the top, you can see that there is a Volvo India company which sort of manufactures the cars and trucks, and each of those cars are basically tested on this track. Now, this Volvo test track has different kinds of road conditions. It has potholes, it has water logged things, it has some kind of a bridge. It also has different road conditions, that is, some with lot of stones, rough array, and then circles. You can go in circles and bends and curves. So every truck and vehicle which is sold in the market is actually has gone through a test drive on this test track, and to see that the factory assembled vehicle is safe. So now we said, okay, let's try our system on the Volvo track. So if you look at this slide, the left-hand side part is the path followed by the vehicle as shown on Google Map. Okay, so you can see that this is similar to the on the Volvo track. So we just took one part of the Volvo track. And then if you, the picture shows you the GPS positions of the truck plotted on the Google Map. That means this is the path on the Google Map, and then this is the GPS. So we had a GPS on the vehicle, and this is the GPS map. So which is pretty good in terms of going over that. And then we compared it with the Logitech webcam based solution. So as you can see, this is the of course, this is the output of the Z stereo camera, but I also showed you that whatever we have built is as good or close to the Z stereo camera. So this is what you can get by purely using webcams, right? Without GPS, just use webcams. But first you need to, of course, go once, train yourself, and then you can see. And obviously this won't be the same as a Google or the GPS location, but this only shows that using webcams, you can find your location and you can map different parts of the region or the terrain. The next task, as I told you, was to see whether we can do collision avoidance. So the idea here is that in this mine, right, there are, okay, let me give you the scenario here. So what happens in a coal mine? Okay, in a coal mine, every day around 4 p.m., they have explosives and excavate piece of land. So they keep going down, as you see, into the ground, and every day they will have a big blast and with an explosive for about half an hour or so. So no trucks, nothing will be moving. They will excavate something, and then these trucks start moving. So for about 22 hours a day, the trucks keep moving along these muddy paths. And sometimes the drivers are tired, and because they also work during day and night in shifts, they have accidents. So these trucks, these large trucks, as you can see on the top left corner, you can see an excavator truck. These trucks are loaded with very heavy material, and they can cause accidents by colliding with the trucks because the drivers are tired. So the mine operator wanted to know whether is it possible for us to at least give an alert to the, if suppose the driver is falling asleep while driving, whether there is an alert which can do, because there are no road signs here, there are no such things here. And they wanted to have a very simple system where you don't want to use expensive things like LIDARs, ultrasonic sensors, radars, and all that. So they just want cameras, okay? They just want to use camera and maybe a GPS and an inertial measurement unit and see whether neural networks and AI can help in that. So again, if you go back to our pipeline, so first we collect data, we train, and then we do that. So this is your task definition. You want without radar, without proximity sensors, and can you find out where my truck is going, and can I find out how far the truck in front of me is? So as I said, there are 4 phases: data collection and annotation, analysis. You select a neural network model, you train it, you test it and validate it, and then you see whether you can do it in real time. Okay. So this is what I will quickly go through. So what is the training phase? How do we collect data? So what we did was we went to the factory and we had the Logitech camera. This is a single camera, not 2 cameras. We just had a single camera on truck 1, as you can see on the left side of the image. And then you have another truck in front of you. And then you have a GPS receiver on both of them, because we need to calibrate, right? We need to understand how far the truck is and how do we correlate it to the size of the image. So we did 2 things. One is the stationary parking lot. We had many trucks parked, and then we moved the truck at different distances from 10 meters, 20 meters, 30 meters, 40 meters, like that. And then we collected a lot of images, how a truck looks from one truck, how the truck looks to the truck behind you, behind the other truck. We collected a lot of data. Then we had one collection of data where 2 trucks were moving on the Volvo test track with these 2 GPS receivers and the camera which is recording the truck in front of the other truck. Okay. Now this is data collection phase. And then we were told that the braking distance of the Volvo truck going at a certain speed is about 25 to 30 meters. That means if you apply the brake, it will come to a stop only after 25 to 30 meters, okay, depending on the speed in which you go. So the task was to ensure that we alert the driver if the truck is less than the safe distance. Okay, so if the truck is very close to you, if the truck in front of you is very close to you, then you should be alerted. The driver should be alerted that it is safe or it is dangerous, right? So now, and then we build the algorithm. So as I said, the hardware is single Logitech HD webcam. You had an NVIDIA laptop to collect the data, not to process right now, but in the collection data collection phase, you only collect data. And then we went to Hoskote factory garage and test track. And then we took a lot of information and images for that. So we all know that human beings estimate the distance in some sense by the size of the object. If the object is far away, we know that it is smaller in our field of view. If it is closer, it will be large, right? I mean the size of it. So we just ran a program called YOLO, which many of you may be familiar, for truck identification. And then we found its bounding box, its size, location. And then we know that we sort of found out that if the size of the bounding box is smaller, then it will be far away. And then that is how do you calibrate with the ground truth. So using this GPS receiver, you know how the trucks are moving, how far they are. Okay. And then we said, okay, let's try known neural network solutions. Okay. So we collected about 1,300 images. We trained the neural network on 700 images. We validated on about 180 images, and then we tested on about 426 images. Okay. So now the question is, which neural network should we use? So we had many neural nets, and as I said, there are many more neural nets which we could have tested, but we chose a set of neural nets like AlexNet, ZFNet, VGGNet, Inception, and found out about these images which we captured in the Volvo factory, and tested them and saw that AlexNet has about accuracy of 94.4%. Now, what is this network? Basically, neural networks are collection of weights, and they pass through a nonlinear function. They mimic our human neural system, and these images then are fed to this neural network. They're trained. It takes a lot of time to train, and then the coefficients converge. And once the coefficients are converged, then these coefficients are then frozen, and then when a new image is given to the neural network, it will tell you what exactly where the objects are, and once you train it for a certain set of objects. So what we basically did was we collected all this data and then we ran this. So let me see if I can show you a video of okay, I've not yet shared. Please tell me if you are able to see a slide.
Yes, sir. Yes. Yeah.
So now what I will do is I will run this video. This video is running at a higher speed than normal. This is the truck which has the webcam, and this webcam is looking at another truck in front of it. And you can see on the bottom, it is telling you the distance between the two trucks. Okay. And on the top, it is say telling you the label, whether it is danger, if it is danger, or if it is safe. Okay. So you can set the threshold when you want. If it is 20 meters, it is danger, or 25 meters, it is danger, 30 meters, it is safe, and so on and so forth. This video is telling you in real time, we are capturing the data, and you are able to see. I'll just run it again once. You can see it is safe now because it is quite far away and it is about 30 meters. But when it comes closer and closer, you will see that the label on the top will be changing to danger, right? So if it is very close, then it will sort of say that it is danger, so it can generate an alert. Now this is a simple webcam based collision avoidance system based on neural networks or deep networks, you may call them. And this is demonstrating this, and this is how the test track looks like. The two trucks which are moving and trying to test out the algorithm. So this is basically what is possible using neural networks. So in the
Sir, you are muted.
okay. Uh, okay, now, so what I wanted to say was that in order to do this, as you saw, you were able to see what I was. Were you? Did you see what? Did you hear me when I was describing the video?
Yes, sir.
Yes, sir.
Okay.
Yes.
Okay. Only when I switched it. Yeah.
Yeah.
Okay.
That's time.
So yeah. So this is a Ramagundam mine in Telangana. And we collected data there in the mine, and we could do segmentation, and that activity of doing it in a mine is will be in the next phase whenever that happens. This is what it is. So what I would like to do is this is one part of it. How much time do I have? How much
So
time do I have left?
still 15-20 minutes.
Okay, fine. Very good. So then I can quickly do that. So this is the first task, as I told you, of Volvo. The next task, as I told you, Wipro wanted to see whether we can do things for Indian roads. Okay. Can I build a data set? Can I do annotation? And can I run some algorithm? So I'll quickly go give you some information about what is this. So Wipro IAC Research and Innovation Network is called VIRIN, and we are building a national data set. We are, in fact, engaging an engineering college students and faculty in an engineering college in Bangalore to help us collect these data sets. So these are things where students and faculty get involved. And this data set, once we create, annotate, label, we will be in a position to share it with everyone in an open source manner. Okay. So Virin is basically an area of collaboration where we build autonomous systems, image processing, computer vision, AI data, and so on and so forth. Uh, I think we have already seen this. This is basically the idea of building a database. If you look at a feature of databases which are available on the net, we have different kinds of datasets. We have a Baidu Apolloscope, Berkeley Deep Drive, Cityscapes, Kitty database, Mapillary, New Screens, Oxford's robotic car database, and comma.ai, and so on and so forth. And each of these databases has different features. Okay. So licensing, of course, whether it is commercial or non-commercial, video and image database, number of images, whether they give you object detection, whether so that the database is manually labeled, semantic segmentation, do they have LIDAR, behavior data, how the vehicles move, different cities, is it single city or multi-city, do you have highways, multi-weather, multi-day? These are various aspects of different data sets which are available for researchers to use, right? Image resolution, frames per second, and so on and so forth. So you can see that some of these data sets do not have, there are some gaps. So what we want to do in Virin is basically to see whether we can address and collect data for for most of the cases, except a few of them maybe. That also we will try and see whether it is possible to collect. So this is a data set collection project which we have started almost more than a year back, or even more than that, almost 2 years back. And we are collecting data. Okay, we are collecting data. And so how do we collect data, right? So typically we need to ensure that we have a sensing platform, as I told you. So we take a car. I'll show you some pictures. We have a camera, we have a LIDAR. Basically, LIDAR is a light detection and ranging system like radar, but uses light pulses. GPS and inertial measurement unit, and driver monitoring system. See, these are in-vehicle sensors. And then we need to collect data live, right, in real time. So we have a CPU, we have RAM, we have a GPU, we have a lot of storage because these sensors generate a lot of data. We have a power supply and UPS in the car so that we can collect it. And then we sort of do an offline storage and processing to look at that. So where do we place the sensors, right? So we take a car. So what we have done is we take a car, we attach cameras, and we inside for a driver, we have a driver camera and gaze tracker to see if the how the driver is driving a vehicle, and seeing whether anything we can do at the health of the driver. Then we have front and rear cameras, okay, and then of course there is onboard computing and storage. So let me show you the pictures. So we have this camera with this car, which has the sensing platform. As you can see, this platform has, I'll give you a closer picture here. Yeah. So this picture has 3 cameras, as you can see. So we have 3 cameras in the front. We are going to collect data with even rear cameras at the back because we also want to understand what is happening behind the vehicle. And this is a LiDAR system. This is called Ouster. And then we also want to collect data of the sounds which when the car is going around. So somebody is honking, somebody is shouting, screaming, whatever. Different cars have different acoustic signatures. So we want to also look at putting some microphones so that we can collect this data, and then also try and put some radar system if possible in the next, as we keep collecting data in different phases. So this is basically what it is. So what is a compute platform? We have an Intel processor based CPU laptop with a NVIDIA Quad Pro. Of course, it has enough RAM, a lot of hard disk, because we need to collect data and save it. Okay. So I will show you a video clip later, but first let me show you some screenshots. These are data collected on IISc campus. So this is the camera image and the corresponding LIDAR image. Okay. So this is a camera image and a LIDAR image. A LIDAR gives you a three-dimensional point cloud. So it gives you three-dimensional data. And once it collects the data, you can view it at different angles, right? You can view the LiDAR data from different angles, and you can see what happens. So these are snapshots. I will show you a video of how we collect data. And then once we collect data, we need to do annotation. Okay, we do annotation. That means we need to do labeling, and that is done manually and also done based on some algorithm. See, once we know how to identify, let's say, a truck or an auto, how do we do is you manually annotate first, image by image, and then you train the neural network. And after that, the neural network can be given, let's say, a new set of video clips, and then it will automatically label the antenna, the objects. So I will show you a few features of that. Okay, so what is an annotation studio? So you need to build a annotation studio, and you present the image, and somebody manually will put a rectangle on top of it saying that is a car. So you can see on the right side, you can look at car, person, bicyclist, rider, bus, lorry, all kinds of things we will put, and then we'll do annotation. So this is how we would build. So an annotation studio is built where you sort of do this labeling, and then once you give this labeling, you will be in a position to drive the neural networks. And similar labeling has to be done in 3D, right? This is the point cloud annotation studio. So when you have LiDAR data, it will give you 3D information. So you need to have 3D bounding boxes or labeling saying that this is a person, this is a car, this is a tree, and so on. And then, as I said, we can also do automatic segmentation by running some algorithms so that you can reduce the work of manual labor. So once it gives you something, if something is wrong, then you can go and correct it. Okay. So similarly, these are all 3D bounding boxes, and we have collected a lot of data, pedestrians, two-wheeler cars. So let me show you these data sets, and let us see if I can just give me a minute. I just have to switch the application, so just share. Okay, are you able to see the screen?
Yes, sir.
Are you? Yeah, very good. So when the car moves in the campus, you can see that the cameras are collecting the image, and the LiDAR collects the three-dimensional image. Okay, so this is IISc campus, and we collect data, and you can see that the LiDAR image gives you the 3D. You can view this image from different angles. The cameras, of course, you can only see it is fixed. So now you can see, right, there's a tractor coming in, and you can see the tractor on the right hand side also. Okay, then there is a car which comes, and as it turns, there will be an auto. There are a few cars here. So this will be the LiDAR three-dimensional data. So why do we need these multiple sensors? Because if I want to do autonomous navigation, then I need to understand the scene, right? And once I understand the scene, I'll be in a position to do something which is plan the navigation algorithm. So now what I will do is I will using this, we have created algorithms. So let me see if I can. Okay, 1 minute. VLC, just hold on. I want to show you one more data. So using this, we have tried to do some. Are you able to see this?
Yes, sir.
Are you? Yeah, you are seeing a truck, a large truck. So are you able to see a video, the car?
Yeah, we can see it. We can see that.
Okay. So now you see that. Okay, let me maybe just stop here. So what we have done is we have collected this data, as I said, in the Indian conditions in the campus, and we have trained a neural network to identify objects. Okay, so this is identifying an object like a car. Okay, this is our near the security gate of our campus, and we then gave the algorithm. We gave these videos. Again, this video is going at a faster than normal, just to save time. And you can see that it will sometimes it will tell you that it is a wrong classification also can happen, right? So sometimes the auto can be thought of as something else, but these are errors which happen in any algorithm. So you can see that the person is walking, so it detects the person. There is a car which goes, but the Tonga or the jet car is not identified because we have not trained it. Okay, so this is a clip is important in that sense, that if you bring in a Tonga which you have not trained, the neural network will not be in the position to uh, identify this. So this is what the artificial intelligence based methods do. So once you do a scene analysis, this is the security camera at the main gate. So it will tell you what vehicles are coming and going, and then you can identify maybe these things. One more last thing I will like to show you. What we did was we went to the Bangalore Traffic Police, and we asked them to give some data of regular traffic. Okay, so let me see if I can show you that. Are you able to see this?
Yes, sir.
Are you able to see? Okay.
Yes, sir.
So this is the traffic video of 2017. Obviously, they did not want to give us new data, recent data. So they gave us old data. This is the traffic camera at the intersection of a place where it is called Garuda Mall is there. Okay. And you can see that the neural network algorithm trained on this data is able to detect different vehicles of the Indian conditions. So we have trained it to detect the lorries, the trucks, the buses, the autos, and of course people walking, all that, right? So there is an auto and all that. Now this kind of algorithm will help us in understanding the scene and seeing whether you can do. Obviously, this is a camera which is at a height at the traffic junction. But for autonomous navigation, we need to understand things around us. So it will be placed in one of the vehicles, and we should be able to detect whether there is an auto in front of you, or a car, or a motorcycle, or a bicycle, or a person. And then we have to understand how these things move, because you can see how people walk dangerously. If you look at this, it is quite dangerous that the vehicles are moving, the people are crossing the road, so it can cause accidents, right? But we are human beings. We are able to navigate in some sense. Of course, we do mistakes and we get accidents happen. So, what the whole idea here is to show that there is a possibility to use machine learning and deep neural networks to understand different kinds of objects, different using different sensors, and also build navigation algorithms. So that's basically what I wanted to emphasize, and let me quickly go back to the last. Okay, so these are the next steps. We need to build neural networks for scene analysis, track objects in the scene, and do navigation algorithms. Thank you very much for your attention, and stay safe and healthy. And I'll be happy to take questions if there are any.
Okay,
Thank you,
sir.
sir.
Sir, we have a couple of questions in the chat box.
Okay.
The first question is, in the Volvo project, are the objects of interest only trucks or different type of vehicles? How are both the natural size variation of objects and distance taken care of in estimating actual distance?
Okay, let me just get this question. Are the objects of interest only trucks or different? Yeah. So in the Volvo project, because the task was only to look at trucks. So we only looked at trucks, but different types of trucks we have looked at. All Volvo trucks, right? I mean, there are different kinds of trucks. There are called excavator vehicles. There are dumping vehicles. There are vehicles which carry the ore from one place. There are different kinds of vehicles. So we tried to look at all the kinds of vehicles which are available there in the factory, and then we looked at. And the both natural size variation in estimating actual distance, because we actually measured the data, right? So what we did was, as I told you, in a parking garage where all the trucks are parked, we measured with a measuring tape, 30 meters, 40 meters, 50 meters, and we took the images from the webcam of one of the trucks, and then we have a collection of images. For when you are moving, when you have two trucks moving, we put two GPS receivers. So we collected the two GPS receivers, synchronized, and then we found the distance in the video clip. And then we found the distance. So we need to have a ground truth, otherwise we cannot label. Okay, and so that's basically what it is.
Sure, thank you, sir. The next question is how to measure the distance between two trucks in the video.
Yeah, so that is what we have the GPS receivers. So we collect the GPS data on both the trucks, and we have a synchronization of the samples of the GPS receivers, because GPS clock is synchronized, and we use that offline and computed the distance between them. Because if I give you two GPS location, I can find the distance because it is longitude and latitude given to you, so you can find the distance, and that's what we did.
Sure, sir. Thank you. One more question. How LIDAR is the best choice for the object identification in 3D view? Is there any other
Yeah.
alternatives?
Good question. Yeah. So LIDAR, I mean, radar, LIDAR, all these are similar things, but LIDAR is a good choice for 3D view. Of course, you can always compute 3D views by taking multiple 2D views also. But in our application, so for example, suppose it is a stationary thing, I can put multiple cameras in a room, take multiple images, and using this depth information, I can reconstruct a 3D scenario in a room. But here in our application, it will be difficult for us because we cannot have cameras because the vehicle is moving, right? We cannot have cameras in front of us or outside of the vehicle. So in that sense, the LiDAR is a choice for 3D view. Will not be in a position to reconstruct unless there are 3D maps already done and they are available to you. Then when you're driving on your highway, you know exactly what's happening, but that is a bit difficult. That's why LiDAR is important for 3D view.
Thank you, sir. Sir, Chirag sir is wondering if there is any possibility for the collaboration for wiring project by any individual or the institute, and can we have the access of the data sets for that? Thank you.
Yeah, good question. Yes, Viren is open to having, as I told you, that we have an understanding with the College of Engineering in Bangalore. We are trying to see whether we can collect data in other parts of the country. So we are we are sort of looking at the auto. We have an association called ARAI. Okay, so this is the It's an association based in Pune. I think they are also trying to help us. We are looking forward. The only issue is that we need to replicate the sensing system sitting on a car, correct? And then the car has to go around and collect data. Plus, you have to take permission to collect data outside in the city from the police. So we have got permission now from January to March of 2021. We can go out in Bangalore city and collect data. So that is now ongoing. That is what is ongoing. But that is for data collection. But once the data set we annotate, label, and we would like to release it to everybody, an open source, a limited kind of data sets, then research can happen. So we can always involve different engineering colleges. Maybe students can do internship on these things. That's basically what we can do. Yes. So Viren is to answer your question. Yes, we are looking for partners, and we also will give you access to the data set once we have proper labeling and we have enough data. Otherwise, it is not a meaningful data set.
Sure. Thank you very much, sir. Shakshi, you may continue now.
There is a question
Thank
which
sparing your time, valuable time, and thank you also for sharing your knowledge with us. It is requested to all the participants to fill the feedback form provided in the chat box. Now, I would like to call upon Mr. Harshul Yagnik, sir, to give the vote of thanks.
Respected Dr. K.V.S. Hari sir, Dr. Chirag Pamwala sir, Dr. Meeta Pamwala madam, my fellow IEEE Gujarat section SPS chapter Execom members, and dear participants. I, Harshul Yagnik, Student Activities and YP Chair of IEEE Gujarat SPS chapter, am very honored to extend this vote of thanks. As William Faulkner once said, that gratitude is the quality similar to electricity. It must be produced and discharged and used up in order to exist at all. So today I take this opportunity to put all my gratitudes in words on behalf of all the Execom members of IEEE Gujarat SPS chapter and SCAT and GSAT SPS student chapters and all the participants. I would like to thank and express my hearty gratitude to our renowned expert Dr. K.V.S. Hari sir for giving your precious time, for inaugurating our two student branch chapters, and for enlightening the participants towards the advanced technology. Sir, you have indeed inspired many participants today to work towards the signal processing domain. I would also like to thank Dynamic Chairperson IEEE Gujarat
Yes,
SPS chapter
inside.
Dr. Chirag Pamwala sir for guiding and motivating Execom members and students and to keep the zeal alive and proactive in all the members. I would also like to thank Dr. Meeta Pamwala madam for her continuous support. Last but not least, I thank all my fellow SPS members, most important volunteers and participants for making this program successful. Thank you. Thank you so much, sir. Thank you to all the participants.
thank you very much. Are you taking a picture, group picture?
Yeah, we are taking group picture, but before taking group picture, I am taking note of presence of
Requesting participants to switch on your video so that we can take a group picture.
have Hardik Pathak from GSET SB with us. And Arpan, thanks to you for organizing such a nice event. Please turn on your videos so we can have a group photo. Yeah, I can see Smita madam also on in the frame. Okay, so Harshul, are you taking a snap?
Yes, I've taken it, sir.
Okay.
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 Thank you very much.
Thank you very much, sir.
Chirag
Hari sir,
sir,
thank you very much for your time. Yes,
Chirag
sir.
sir, we need to give a memento to Hari
Yeah,
sir.
yeah,
That's
please go
big
ahead. Please
honor.
go ahead. Please go ahead. Yeah, please go ahead.
As a token
Yes.
of gratitude, we would like to give you a memento on behalf of IEEE SPS Gujarat section to you, sir.
Thank you very much. Thank you.
Thank you very much, sir. Thank you, sir. So I'll be.
Thank you, sir, for giving time, sir.
Thank you. Thank you.
Thank you very much.
But please go ahead.
All the best. I hope the talk was useful.
Yes, sir, definitely. Definitely, sir. And I think that many student members are there, more than 80% student members are there right now in the talk. And obviously, they will use this idea for their research also.
Okay.
And we will keep this talk on the YouTube channel also, so they can have they can view this talk later on also.
Okay. Okay.
Okay,
Thank
sir.
you very
Thank you,
much.
sir. Thank you.
Thank you. Have a good weekend and stay safe.
Sure, sir. Thank you.